please start today by just sketching the function f of x equals sine of x on your paper. All right, so when you're going and making this sketch, we're talking about sine, right? Where does sine start? The top, the middle, or the bottom? The middle, yeah, because sine of 0 is 0. And then is it going up from there or is it going down from there? Yep, it's going up. And so then just based on that information alone, we can see that this is the way that sine is going to be looked. All right, so now that we have a rough sketch of sine, on the same graphing grid, on the same little overlay where you sketch that, please now sketch the derivative of sine of x. Sketch out what you think that derivative would look like. All right, so in order to make this derivative, let's start, and let's just grab a few points here. Like at 0 here. Is my derivative positive or negative? Positive, yeah. And so I know that it's going to be someplace up here where my point's going to get plotted. I don't necessarily know where exactly, so I'm just going to put a point up there someplace. All right, then what about, let's go here next. What's the derivative there? Yeah, that one is exactly 0. We can know that for sure. And then after that, like if I go over to here, is my derivative positive or negative? Negative. Now you'll notice that it's kind of the same steepness as it is over here. It's just going down instead of up. And so we could expect it to be about the same distance down. And so I might like plot about the same distance away. All right, then if I go over to here, what's my slope here? 0. And so my derivative is 0. And so I can plot the point at 0. And we could keep going through that same thing. And so we'd be able to see that we end up with a sketch of a graph that looks roughly like this. Now it just happens that if we actually calculated the exact slopes here and here and here, that it actually does give us the same values as what we saw for sine, which is 1. They actually have slopes of 1 there. And so based off of that, we could actually make a bit of a rule, because this blue graph also looks familiar. This blue graph is the graph of what function? Yep, it is cosine. And so we can then see just graphically that if I start with sine of x, the derivative will be cosine of x. All right, and we can actually even figure out what the derivative of cosine is similarly. So let's take a moment and try to figure that out by sketching, make a separate sketch this time, make a sketch of cosine, and then sketch the derivative of what cosine would be. All right, so when I go to sketch cosine, where does cosine start? The top, the middle, or the bottom? Cosine starts at the top. And so this is our graph of cosine. All right, and then I want to start making the sketch of my derivative. Well, I can see where the slope of that is 0, so I can go ahead and put in those zeros right away. But then in between there, like at this point, is my slope positive or negative there? My slope here, it's going down as I go left to right. That slope is negative. And so it's going to be down here. And then the slope over here is positive. If I sketch in that graph of my derivative then, this is what I'm looking at. What is this graph? This red graph up here that is our derivative, what equation represents that graph? Yep, it is negative sine. And so then just by looking at the graphs, we can figure out, well, cosine led us into negative sine then, because of course sine always starts in the middle, but normally sine goes up from there. Since it's going down, that's why it's negative sine. All right, looks like we just figured out 2 new derivatives, right? Let's add those to our derivative rules page. So in your notes, specifically on the derivative rules, please add these 2 new rules. And notice you're going to want to leave space underneath them for 4 more, because of course there are 6 total trigonometric functions. But today we're only looking at these 2. So now to practice using our new derivative rules, please find the derivative of this function. All right, so as we take a look at finding this derivative, you notice that we have a 2 pi that is being multiplied by cosine of x. So then, do I need to use product rule here? Well, I'd say that you can, but actually you don't need to. Because that 2 pi at the start, what do we call 2 pi? It's a constant. And so I don't need product rule because I have the constant multiple rule. Now, as we saw yesterday, you still can use product rule. You're just going to be doing more work than you need to. So what's the derivative of cosine? Negative sine, which means that it's going to turn this into a negative 2 pi sine of x. And that's it. That's done. That's all you need to do. Now, if you did think, okay, I'm going to go ahead and use the product rule here, and you had done it that way, I mean, you could do that. It'd be original times the derivative plus the derivative of 2x, which is, the derivative of 2 pi, which is 0, times the cosine. And notice that that whole 0 times cosine would just become 0, hence leaving us with what we ended up with anyway. It's just a lot more work to have to do it that way, and we run the risk of forgetting that the derivative of 2 pi is 0. All right, next problem. Please find the derivative. All right, now as we take a look at finding this derivative, we have e to the x and we have sine of x. Are we going to need product rule in this case? Because the e to the x has the x in it, it's not a constant. The sine of x, it has an x in it, so that's not a constant. So we actually do need product rule here. And so it's going to be original times derivative. So the original e to the x times the derivative of sine of x is cosine of x plus derivative times original. And the derivative of e to the x is e to the x. And then times the original sine of x. And really that's it, that's done. I mean, we could try to go ahead and clean it up a little bit. Like you could write it as e to the x times the quantity cosine of x plus sine of x, but you don't strictly have to. All right, so the next step, we're going to find the derivative of this function. As you take a look at this one, we have a little bit of a challenge ahead of us though, right? Because we have a product rule, but we don't have a quotient rule, which is what we would need for taking care of this division. I can only actually deal with this if it's a product. So does that mean we're stuck? No. Because we actually can rewrite this function as a product. So I'm going to just start by rewriting f of x as pi cosine of x, the top, times what? And then, since that x is on the bottom, remember that's like x to the 1, I can put it into the top. I turn that into x to the negative 1. And I want it in that format because now I can actually take the derivative of it. So now you can take our derivative, and yes, you will need product rule. All right, so what do you think? That look good? So you'll notice that this is kind of what we would want to do intuitively, right? But this is not quite right at the moment because I just did the derivative of each part. Remember, for product rule, we have to do original times derivative. So we have to do the pi cosine of x times the derivative of x to the negative 1. So that is the negative 1 x to the negative 2 plus, now we do derivative times original. So that's going to be pi times the negative sine of x times the x to the negative 1. Now that's using product rule correctly. Stay cognizant of that, and that's always going to be a big help. I would like to throw some of those in so that we're really thinking about what we're doing. Now I do want to clean this up a little bit at least, because I have those negative exponents sitting in there and a lot of extra parentheses that I don't need. So I have this negative 1 here. I can go ahead and put that out front. So this becomes a negative pi cosine, but I got that x to the negative 2 too, so that's going to become a fraction. So negative pi cosine of x all over x squared. There we go. That's a bit cleaner. And then this next term, it's also negative because of the negative sign. So that's minus pi sine of x all over just x. And if you wanted to, you could even turn this into a single fraction. You know, you could be multiplying this second fraction top and bottom by x, and then you could combine them. Feel free to do so, but you don't have to here. All right, and so for our last problem, please find the second derivative of this function. And of course, the first thing we do in finding the second derivative is that we find the first derivative. And so when we find that first derivative, for this first term, we're having to use product rule because we have x times sine of x. So I do original times derivative plus derivative times original. And so that's where we get this part from. But then we have this plus here, which is this plus. And so then it's just derivative of the next term. So the derivative of cosine then is the negative sine. Now, while we could just leave it there before going on, we want to clean this up before we go and try to take the derivative again. And so when I just get rid of a lot of those excess parentheses and all that stuff, I end up here. But you notice this can simplify even more, can't it? Because you'll notice here that I have sine x minus sine of x. That, of course, is going to just add up to 0. So actually, f prime of x here just equals x cosine of x. Actually, finding that first derivative gave us something simpler than what we started with. It's rather nice. But we're not done yet, of course, because remember, we are finding in this particular problem this second derivative. So now find the derivative of the derivative. And yes, you will need product rule for that part. And when we do so, we end up with negative x times sine of x plus cosine of x. Or if you prefer to go ahead and make it even a little bit simpler past that, you could even then write that as cosine of x minus x sine of x.